Yep.
All right. Once again, hi Facebook world and everyone else that's on Facebook. You guys are on Facebook. What is
I
it?
don't even
Snapchat?
use Facebook.
All that stuff, yeah. I'm old. Okay. All right, so here's number 23. Let me first read it. We're going to set it up. It says, in order to estimate the height h of a flagpole, a 5-foot tall male, there he is, look, happy little guy with one really long arm there. Sorry, I'm not the art teacher, as you can tell. 5-foot male student stands so that the tip of his shadow coincides. Ooh, that's a good word. What happens when it's cold outside? You coincide. Get it? Stupid joke. All right. Just stick with teaching. The scenario results in two similar triangles as shown in the diagrams. Can you see the two triangles?
Yeah.
With the funny little dude in there. So guys, check it out. We really have a triangle right here, down through this little guy, and we have the big triangle created with the flagpole. Got it? All right. So why? First of all, number 23 says, why are the two overlapping triangles similar? Why is this triangle the small one created by the little dude, and the big one with the flagpole?
One's just smaller. Yeah,
they're smaller, but how do you know they're actually similar?
Same angles because two of the lines are like the same angle. Yeah. I don't know how to explain it.
All right, you're on the right track. You're exactly right.
90-degree angle.
Line, yeah, this exactly. There you go. This is 90. This is 90. Oop, that was great. This was 90. We'll get better at this. So what can you tell me about these two lines? If the angles are the same, what can you tell me about those lines?
Same.
But they're what? Say that word again.
Similar.
Parallel. Yes. All right. So this line is parallel to this line, and that's how we can establish that all of the angles are the same, because this angle is the same as that one. This one's obviously the same as itself. And then this angle is, ooh, this is one of your terms from back in the day, a few weeks ago, several weeks ago. What are these two angles called? What kind of angles are those? When we have parallel lines cut by transversal, remember all that stuff? I know you slept since then. What? Ooh, Shazam, nice. These are corresponding angles. All right, because they're in the same place. Okay, Shazam. All right, so now we need to solve it. So that was 23. Why are the two angles similar? Or the two triangles are similar because of what we just talked about. All right, number 24, using the similar triangles, write a proportion that models the situation. All right, we're solving for h. I always like to start with h in my top left spot in my ratio here. Okay, so we're going to solve for h. Okay, so which side of the smaller triangle corresponds with side h, the flagpole?
The 5-foot.
The 5-foot dude, right? Little stick man right here. Okay, so I'm going to put h over 5. Seriously? All right, so we're going to go h over 5. And I want, since we started with a big triangle, I want the length of the big triangle, which is what?
No, it's 18.
18. So I started with the big triangle on top. I'm going to stay with the big triangle. And then what does 18 correspond with on the smaller triangle?
6.
Yeah, 6. Boom. This is the hardest part, guys. Once you get it set up,
Then you're done.
boom. Okay, now we're on the home stretch. Okay, crank it out. Here we go. We're going to cross multiply.
90.
Ooh, somebody already had the math done for me. Thank you for that. 90, if we take 5 times 18, I'm going to take your word for it. That seems reasonable. And we're going to divide by 6. Now, more mathematically, what we really did was this is 6h equals 90. We're going to divide by 6. Now I'm at this point right here. Who's got that answer? Anybody?
It's 15.
Ooh, Shazam, thank you. All right, so when we divide this out, we get 15. So that tells me what? What I find?
The height.
The height. The height is 15 what? Yeah, look at our labels, look at our units. It's 15 feet. That's the height of our flagpole. All right.